Hi, my name is Piotr Gródek and I'm a lead data scientist at deepsense.ai. Today I will talk about coding agents. This presentation is a part of our internal project, and I wanted to start with kudos for people involved at different phases in the project: Max, Alan, Eric, Wojciech, and Patrick, because without them this presentation would not be possible. Our agenda is this. We start with a short introduction to the topic, then jump to learn what is going on in the field. Next, I will show what have we done and end with a summary and some hints for you. Quick introduction to some terms to understand this talk. LLMs, large language models, basically are language models with a lot of parameters, gained huge popularity due to ChatGPT. Just think of models like GPT-4, Llama, etc. AI agent is a computer program or system that can perceive its environment, process information, and make decisions or take actions to achieve specific goals. Agents appear in different contexts, such as games or robotics. For example, in reinforcement learning, agent is a component that makes the decision which action to take based on the internal logic and known environment state. And what is coding agent? Coding agent's main objective is to generate code as a programmer. And during this talk, we will discuss certain types of agents, which main characteristic is that they are based on large language models, LLMs. Idea is quite simple. It is very easy to just ask a model to write some code for us. Then we can provide feedback like fix me this, I don't like it, or blindly ask for self-reflection. So a model can fix its output. It works quite often quite well. Obviously, it leads to key observation. If such iterative approach yields nicer results, then it is reasonable to automate it and extend it. It would also be interesting to increase complexity of generated programs by having more files than just short snippets copied from Playground. And why do we need an agent? Simple code generation using LLM does not work well for complex situations, of course. A key innovation in coding agents is about surprising generalization and few-shot capabilities of LLMs without costly training. And agent usually will have components such as memory, because memory is necessary to keep track of tasks, history of actions, results, etc. Next, we can have some dedicated roles. So planner can come up with what to do or how to do in terms of steps. There is also a need to interact with outside world by acting, by calling a function, writing a file, etc. Results can be improved by feedback, as we saw in previous slides with self-reflection, or by human interaction. Finally, agent needs to be aware of necessary context, because there may be existing files, functions, libraries, or other kind of information which is useful to achieve goals, right? Now I'm going to describe a few interesting open source projects which are relevant for coding agents. I will also show a few examples of agents or techniques to address certain arising issues. Let's start with GPT Engineer. It's an agent which focuses solely on code generation and related tasks, implemented as a set of scripts, basically. In contrast to other projects, it has a predefined steps and execution order. It also asks user first a couple of questions to clarify project scope. It improved over a short amount of time, as you can see on the image on the right, and has a clean code and easy code to understand. Therefore, if you want to start with coding agents, I think it's likely the best starting point. Baby AGI Baby Coder, it is somewhat well-known project. Baby AGI is a general agent to perform tasks. It has specialized version to write code. This is the Baby Coder. It creates and prioritizes tasks, executes them within some context, and stores results in vector database. Tasks, of course, use results from the previous tasks. Unfortunately, it generates a lot of API calls, which is very costly and slow. Plus, if you care about human feedback, it has really weak impact on agents' actions and behavior. In the end, from our testing, it seems like results are worse than GPT Engineer, and code of this project is much harder to understand. AutoGPT is another popular project, much more mature than Baby AGI. It is also a general capable agent, which includes also code generation. It doesn't have a specialized version like Baby AGI, but it works. Major advantage is an ability to use lots of tools implemented as plugins and a very active community, which means there are a lot of plugins for different kind of tasks you can get for free. Unfortunately, there is one problem, that it also can get into infinity loops of performing the same action over and over. Additionally, memory information retrieval is not perfect, but still works good enough to create some code. Or still, we tested it, and in our testing, it performed worse than GPT Engineer. Jarvis, known also as Hugging GPT, is not a coding agent. However, it orchestrates AI models to solve user tasks, so I think it's still related to our topic. It can execute many tasks in parallel and is aware of task dependencies. How it works? It has 4 stages. Basically, it's a 4-stage process. The first component is task planning. So it generates a list of tasks, execution order, and resources dependencies among tasks. Then it has a component which selects model. So it finds relevant model based on the description, like from the Hugging Face cards, filters by task type, ranks by number of downloads, etc. Then we have specialized model to execute the task. And the execution is based around direct acyclic graphs, which means they can be executed concurrently if possible. At the end, after the graph is finished with all the tasks, there is final step, which is response generation. It creates a concise summary from previous stages, combines inference results in structured format. So for example, if we had an image, then it will return bounding box and maybe confidence and such data. And combining it, it finally generates a response in a friendly human language. Next is very interesting project. Voyager is LLM-based lifelong learning agent playing Minecraft. It sets the objective for itself, which means it does not have a predefined goal. It's not like a user asks, okay, so solve me Minecraft or do something in Minecraft. It comes up with its own agenda. And it's a very interesting idea because it writes reusable and composable code to build more complex solutions. How it does it? So it has a code database. So it generates a code, stores it in the database, and then it can retrieve for code building its own tools based on needs. So it can reuse the code it already created. It can build more and more complex functions. And interestingly, it also has a self-verification component that checks whether the implementation is in line with the objective it has, because it figured out some objective and it tries to solve it. Now, what kind of feedback can guide this agent? So, of course, there's environment feedback, like in the game. I cannot make, I don't know, iron chest plate because I need 7 more iron ingots, right? So this is a feedback like, okay, now I need objective, generate 7 more iron ingots, and the agent will write code for it. Also, it's possible that the code will fail, so there will be execution errors from program interpreter that reveal any invalid operation or syntax error in programs. That's other kind of feedback, which can be sometimes fixed by the model, like GPT-4. Then self-verification for checking task success. So there is a specialized component, critic agent, and it checks whether the program achieves the task. If not, it provides critique by suggesting how to complete the task. So it's also based on LLMs. In the end, it's also very effective as the code is reusable for further runs because the code database can persist between runs. We should also notice that Minecraft API is quite easier to work than general programming task because there is no need to call any external libraries or no external APIs and such things. And it's written in JavaScript, if I remember correctly, as you can see on the images. Next is a paper. And the reflection is a research paper which shows that providing agent its previous attempts and self-reflection helps a lot. Basically, it's a technique to improve agent's self-fixing capabilities, which we discussed previously. A coding agent often requires to correct some bugs or troubleshooting code because if you try to run code snippets, then maybe there is some syntax error, sometimes something stupid. So it's good to fix it. Authors reported improvements over a baseline across diverse tasks, such as sequential decision making, coding, language reasoning, and so on. And evaluation of the coding task, which was interesting for us, was based on the TDD. So model generates tests first. It's not like they have tests in the first place. So the model had to write tests for the task, and then the model tried to generate code which could make the code pass. And that was the feedback they used to guide the code generation. Interestingly, they used Python and Rust. Another interesting technique which might improve coding agents' performance is tree of thoughts. Reasoning and planning can perform worse due to inability of LLMs to perform backtracking. Because after we generate a worse token, so the network generates maybe not the perfect token for the next one, the next token must be consistent with it. It means it is irreversible and code ends up incorrect, worse or just wrong, right? We cannot go back and, okay, that token was incorrect, like maybe it missed some parentheses or something like this. And our solution is we can adapt research techniques like DFS, BFS, ASTAR, Monte Carlo tree search with the LLM heuristic, which ranks and evaluates thoughts. What are thoughts? Thoughts are step-by-step reasoning chunks. And on the image on the right, you can see standard input-output approach, right? This is the first one named A. Then there is this known technique of chain of thought prompting, which is like ask model to write step-by-step leading to an answer. Like, okay, so I want an answer, but make a step-by-step approach. So make some bullet points and so on. It helps the model. There is also some extension of that, which adds also this heuristic based on ranking average or making average on top of that. And finally, this is the authors proposed. You can see that the dots are in the tree structure, right? And you can see the green ones are the one which were basically having high score to prefer. Red ones are something that like was rejected. So we can also think like min-max tree search for playing some chess games or something like that. And it works much better for tasks which require backtracking because it's created for that. Authors tested on crosswords and 24 game. 24 game is like you want to have a set of operations which sums to 24, basically. And crosswords are like you have a puzzle, so you need to put words, but words can be, you need sometimes to correct the word, so go back and choose different word. They also show this technique that it improves self-consistency for creative writing tasks. However, instead of general prompts, they use specialized for each task, which means it won't work for different problems out of the box. You need to fine tune the prompts to make it work. And because each thinking step needs to be evaluated, ranked, and so on, it is more slower and costly method compared to the baselines. Finally, Gorilla is a very nice project because it helps with API hallucinations, and it also makes possible to use APIs even if it changes, so it can learn online. However, it focuses on smaller code snippets, like a couple of lines. Major points. So zero shot and retrieval are two modes of operation. Zero shot is based on a custom LLM based on Llama 7B. It was trained on code for leading machine learning APIs. So they trained on Torch Hub, TensorFlow Hub, and Hugging Face. And you can test it very easily because they have Colab notebook. However, they expand to other domains like Kubernetes, GCP, AWS, Open APIs, etc. And because they fine-tune the model, it performs better for such tasks. But I think most interesting is the second mode, which is retrieval based, because the retrieval has a capability to learn new API from documentation during test time, right? So because if you fine tune a model on some code API, then it won't work if there is a new version of a library. Maybe the API was changed, maybe some refactor, like semantic breaking change was introduced, like model is not aware. So this allows to make the model aware that, okay, current version of, I don't know, Pydantic has this API, use that, right? But that's not the end, because also the model is fine-tuned for retrieval mode, which means they also have specialized prompts to help with the retrieval process. And huge point I can give to this project, because it has a commercial friendly license and also has a data set of over 11,000 instruction API pairs, which is great for testings. But unfortunately, it's also on smaller chunks of snippets. And now, after we are done with the review, let me tell you what we did in our project and what we learned from it. So there are cool demos for coding agents, but mostly basic popular small applications like apps like To-Do, Weather, etc., or games like Snake Flappy Bird. And they seem to perform quite well for those kind of programs. So the question is, how far are we to automate professional data science? Should we be afraid that we will lose our jobs? So in our project, we had simple, maybe multiple goals. So the first goal was to discover existing approaches and tools useful for our daily work, like copilots or maybe some different agents that are doing some great work. Learn about limits and challenges, so what is possible, what is not possible, and so on, and gather some empirical experience. And over the span of about 2 weeks, we had a hackathon to develop coding agents to understand the problem space better. And benchmarks, basically, it's very hard topic to discuss for this kind of tasks, because existing datasets are focusing on small code generation at function level, maybe a single page of code, or about website applications. Basically, it's like documentation snippets, not really building complex programs. We wanted to test it in a much more realistic and challenging way, so we created 7 still quite easy and small projects in different domains. So, for example, we have a problem of detection of license plates in images or Pokemon classification, which is computer vision tasks. We have text summarizer and named entity recognition for NLP kind of tasks, and Spotify general classification, which is for tabular case. And for evaluation, the results, we use some easy and obvious metrics like, okay, can code be executed? It's 0 or 1. And the second is how much does it cost? So how many tokens we use to generate the answers, and what is the execution time? But at the end, we must review the code to see how good it is, because it's not obvious how to automate it. There are many good possible solutions, or subjective things like code quality. It's very hard. Okay, we could use model, but we shouldn't trust models that it can understand what it's doing in terms of judging code quality, indeed. So here is example of input we had in our small data set. It is for Pokemon classification, and this is the input that we put into the agent we created. And we also prepared a script to fetch a data set. So agent not only get the input prompt, the specification of a task, but also had access to data itself. And here is example generation. So on the left, you can see the structure of files created. So you can see logs files like tracing, the intermediate steps, configuration, costs, and so on. You can also see that it created a complete project. So it has tests, it has setup py, it has readme, and multiple implementation files. Some are scripts that you can execute, like train.py, and some are reusable components, which means the agent created code that imported the other files to use the functions from that other file. And finally, it's a bit less work than copy pasting from Playground, right? So it's automated. And first agent is plan, execute, loop 1. We implemented a few iterations of this approach, and here I only will present the final one. It performed the best in terms of code completeness. On the right, you can see a simplified diagram of the flow, because in reality it's much more messy. Basically, it's a mix between predefined steps and planner-based agent. It also has a few specialized roles you can see in the diagram. And we also have prompt engineering. So because the code generation is like very specific for data science, we use some special words to make sure the prompt is like following what we want from data science projects more than general application. To keep costs lower and also time, we extracted signatures and doc strings, and then we stored them in vector index. We used Facebook library phase, which allowed us to perform semantic search and choose only the relevant functions to the task, which means we put only the signature and doc string into the context which was sent to the model, which guided and helped to reuse that knowledge in code generation. Also, code retrieval can use knowledge about task dependencies. So if there is a task that depends on some other task, that knowledge also is utilized to make sure that it can reuse the results from the previous one. And files are refactored to fix issues. So this is this self-reflection step to polish final outputs, because sometimes there are some obvious issues with the code that can be fixed by the model. Second, agent does not use planning, like it doesn't generate a list of tasks to execute, and it is based on React agent approach. And React is based on this idea that it generates a sequence of thoughts, actions, and observations. And this guides the next thoughts, actions, and observations. So agent has a thoughts, okay, I need to do this, then takes action, like, okay, I will create this file. It does it, and then it has observation, the file was created. Then it can see this in the context, and it decides what to do next. So it has the next step of thoughts. In the end, it is fully driven by model reasoning capabilities and its context content. How it works. So we start with generating technical details from initial prompts. So we take the first prompt, we identify the domain. So, okay, this is NLP problem. What kind of type of the problem is, for example, text classification. Then we also try to estimate, okay, to which model should be used. And for example, it will be BERT. What kind of metrics should be used? What is the data set? What is the raw data set location? And so on. Then we execute its heart. So this is this React-like component. So it's iterative agent, but instead of having those thoughts, action, observations, it has different kind of operation, which is create, edit, pick, delete, and finish. Only after some warm-up iterations, action agents learn about finish operation, which means we forced it to do some work before it can quit. A pick operation is implemented like open a file and paste it into memory, which is then used in model context during generation. Also, pick, which is, I think, quite interesting feature, can inspect dataset files. So, for example, if we have some tabular data like CSV file, the pick can like take this file and pick and see what are the columns and let's say 10 rows of this data set. So it can use that knowledge to guide code generation, like, for example, performing some transformation to the data set. And edit operation has full file content in context and outputs a new content for this file. Compared to the previous one, it is much more creative, but also more costly and time consuming to run, because it's also like step-by-step execution. We cannot easily parallelize the execution, and also it requires bigger context because it doesn't have this retrieval mode. Everything must be put into context, which means sometimes if the task is challenging for the model, it might require more bigger context. So if we have GPT-4, then for example, 8K will not be sufficient to run. So we had to use like 32K to run some generation for some problems. And it also is a bit harder to control than the previous one because you are not sure what will and when be executed. Context is important, so the third agent tries to address that. So, for example, write me a function to triangulate set of points. It's not clear what should be the outcome because computer vision might mean something different than in computer graphics project. Maybe a model should be deployed on a mobile device, which limits model selection, or maybe it can be bigger, so we can have a beefy GPU, so maybe we should use more complex model for the task. Maybe we should use specific tech stack because there is some preference, or I don't know, we, for example, prefer PyTorch than to have a Keras code. And this design clarification tool is a simple agent to cooperate with a user to generate missing details and potential solutions. So the prototype is like this. We have iterative process to clarify the prompt I showed you. The agent comes up with a set of questions and clarification required to this prompt. Agent then comes up also with answers to prevent extensive user interrogation because it will be tiresome if you are interrogated by the model. Do you need how many VRAM you need for this model? Do you need something or something? It will be tiring for the user. However, the user can edit everything, which means the user can add, edit, or delete questions and answers. And also after this discussion with the user, it has a single pass of self-reflection. So there is a reviewer, like a senior Google principal developer. Please take a look at this proposal and do you see anything we are missing? Something like that. It provides some output which can be used to improve the final results. And at the end, the user gets not only structured output like a JSON file, but also unstructured summary of the design in the text format you can see on the images, basically. And why we should do that is because sometimes it helps to align agents with strategic project needs and also fill some gaps. Maybe there is some detail in the project that is missing, we should provide to the model. And during testing, we encountered a few funny situations. And in first case, the first one agent wrote tens of the very same test in single test case. So basically, it wrote a lot of the same assertion, nothing changed. And we believe you should keep your agent warm, which means don't use temperature 0 for creative tasks, especially. Also, using higher temperature is good because you can come up with more robust design because it allows you to capture more strange situation as well. Another two funny situations happened to our agent number 2. So the more creative one. Agent has limited capabilities, so it's not possible to do anything with it. And due to some bug, our dataset downloading script did not execute, so there was no data. And agent saw that and invented his own download data Py script and tried to run it, which obviously failed because it's not possible for him to do that. And poor agent decided to spend eternity in trying to fix and hallucinate how it runs and fails as files did not appear. And this is a lesson to gracefully handle errors and use iterations limits. Don't allow agent to loop to infinity. The third situation is similar to the previous one, but it behaved a little differently. So instead of trying to hallucinate dataset and trying the best to solve this problem, an agent come with a new action type, contact client, because no data, you need to call the client. So this also agree with you should to validate your output, or maybe provide capabilities so the agent can chat directly with the client and chase him for data. And finally, our general lesson is that agents produce good-looking results on a glance, but still it's a far cry from working and professional level code. And why? Code generation is still not great. So GPT-4 works the best from what we have tested. Likely the code is like very similar to what you can find in tutorials or some random open source projects. So it's not like professionally written. Mostly like simpler cases, not handling errors and so on. Prompt engineering helps a bit, but there is still the problem of hallucinations, like it can write code which does not work, or there is this issue with knowledge cutoff, like the libraries can change interfaces. To solve them, we can either train better models, like in the case of Gorilla, or maybe apply some other techniques I presented earlier, like this retrieval-based approaches. Also, in terms of bigger context, because okay, maybe we don't need retrieval systems, let's increase the context. The first problem is that it's far from cost effective. Also, the alignment with user instructions seems weaker, which means model quite often can miss some instructions you provided in the prompt. And at the end, retrieval augmented generation with specialized prompts works quite well. So we observed that in our agent number 1. So it seems like it is a good solution to many problems. Also, specialized roles perform better than general ones, and you should right now prefer predefined steps over dynamic planning. Maybe in the future models will improve thinking capabilities, but right now it's better to have some predefined steps. And if you are thinking, should you be afraid? Then no. However, I think it's better to start a project with some template and use Copilot or maybe some other assistant like agent. For example, we contributed to Codium AI PR agent, which helps with code review and works quite nicely. And about some technical hints, if you are interested, context is important for tasks. You need to inject enough to align with the goal, but if you put too many specific things, it might hurt performance. Prompt engineering, of course, is important but tricky. So it's tricky to test because sometimes you change unrelated word and it changes drastically results. You can try to add, for example, Pythonic code, which generates different kind of code than OOP. And better guidance is helpful, so you can focus on nicer examples models saw during training. So try to use words you saw in higher quality code bases. Now, planners and goal generation is not something working well in practice. So predefined steps and dedicated tools are way more effective to solve tasks today. And if you want to have planning and goal generation, then take care of looping and that iteration limits and cache or detection of such behavior. And this is always true. Specialization beats generalization. Try to specialize roles in your agent: code reviewer, code writer, project manager, etc. So divide and conquer. LangChain is enough for dirty prototyping and to discover ideas, but often your own custom implementation will be much better. It will be cleaner and performing better in terms of performance. You can also mix different models. So GPT-4 for code generation, but use GPT-3.5 for tasks like summarization. Add monitoring and logging of execution. Tracing is super important to have for debugging and inspecting why the model did something. And structured answers are great to have because some problems are easier to just write in code, like you get input and just run this code. It performs better than having agent which should do it. You can extract JSON, XML, which often works good enough. It's doable with prompt engineering and parsing. And you can start with regex or OpenAI functions, LangChain extractors, or things like guardrails, or even grammar-based sampling, which is doable if you have self-hosted model. And finally, autonomous agents not only for coding will likely gain more popularity because they are a smart way to utilize power of large language models. It is still early phase, which means there are a lot of opportunities to make an impact. And moreover, it is quite enjoyable topic. Agents can write code, but also play games like Minecraft, generate South Park episodes, or like you can see on the image, simulate a small village with multiple independent beings interacting with each other. So at the end, I hope this presentation inspired you to try it for yourself and try to write your own agent or play with existing one. Thank you.